Hello, we are going to talk about brain tumor segmentation, which was a paper published to the Medical Image Analysis in 2016. So, these are some Greek words for tumors that are not very easy to segment because they grow like tentacles into the brain, and it's blurry, there's no contrast in there. So what can we do, because we have to detect them to save lives of people who have them. Maybe we need like GPU or a supercomputer. The special challenges are very vast, but these special properties to biological structures, which is that if you're a tumor cell, you're most likely next to another tumor cell, as in biological structures have integrity, they are very contained. So how can we use such intuition to build specialized models for our problem? The solution is a two-path architecture where we have a smaller mask to figure out the details and a larger mask which is going to keep tab on the global context. Such a system can be hybridized with like a hierarchical system where the first one is we're just taking the input right into the two-path system. The very last one is we're giving the very last input a lot of weight, almost like this is sequential data, and the second one is in between. So now we have a lot of models and which one do we choose? So we come up with a scoring thing for these are binaries, and we won't go into the math here, but because of this, the model also needs to be trained 2 different times. So with our fancy scoring system, here we have the scores for the different ones, and we can see that the very first architecture is the one that's like the state of the art. So obviously the image data are not sequential. And here we can see that such a design where we take all the details in like the hierarchical sense and then we feed into 2 things. It's like the ticket. And here we can see how we use such state-of-the-art fancy genius architecture on a competition and how it just outperformed every other whatever model there is. And the time seems to be from 25 seconds to 3 minutes on average for this kind of automatic segmentation, and something that is pretty serious. So yeah, as long as there's like sufficient GPU, this is doable. They did it. So that one thing I was wondering about was why they came up with that model where they had emphasis on the inputs, like it's sequential when it's not. If they talk to like a professional, would they have still come up with a model? And I feel like a lot of times academics, they come up with fancy models that's not practical because they need extra things to test and to write about. But how can this kind of knowledge be used in other problem areas so people can spend less time solving problems?